Welcome to my video on Algebra 1, Unit 1.2, aka Special Cases, No Solutions, and Infinite Solutions. In our last lesson, we solved equations and always found exactly one solution, like x equals 5 or x equals 10. But what happens when an equation behaves differently? Today we'll explore two new special cases. No solution, which is denoted as that, which also means the empty set, which means that there's no value that makes the equation true. So you would result in something like 5 equals 7, or infinite solutions when every value makes the equation true, like 0 equals 0 or 5 equals 5. This might seem a little bit strange at first, but understanding them is crucial for recognizing when equations don't behave the way we expect. Before we continue, let's review a question from the homework with one solution. I am pulling this from our homework on one solutions number 5. 6x plus 2 equals 4x plus 14. So firstly, you would subtract 2 from both sides. So 6x equals 4x plus 12. Next, you would have to subtract 4x from both sides. So subtract 4x, subtract 4x. So 6x minus 4x is 2x equals 12. Then finally, you would divide both sides by 2 to get x is equal to 6. So when you plug this back into the equation, so 6 times 6 plus 2, that is equal to 38. And 4 times 6 plus 14 is also equal to 38. So that makes x equals 6 a solution to number 5, aka 6x plus 2 equals 14x plus 4. Now let's get into the actual topic called special cases. What if we get a false statement while solving? So let's start with 3x plus 5 equals to 3x plus 8. So when we subtract 3x from both sides, you would notice that x completely cancels out. So you're left with 5 equals to 8. Note, 5 does not equal to 8. 5 will never equal to 8. So that makes this a false statement. So no matter what you plug into x, let's say, let's just run some examples real quick. So let's try plugging in x as 0. So 3 times 0 plus 5 is equal to 5, and 3 times 0 plus 8 is equal to 8. So that means 5 from the first equation and 8 from the second equation. So these clearly are not equal. So that makes our equation answered as no solution. So when you end up with a false statement, the equation has exactly no solution. There is no value of x that will ever make this equation true. So when you're asked to solve a solution, when you're asked to solve an equation for x with no solution, you can either write out the whole thing. So I would write no solution, or you could use the notation for it this. Next, we can go, what if you get a true statement instead? So a true statement is like this. 4x plus 6 equals 4x plus 6. So when you subtract 4x from both sides, again, the x's cancel out. So you're left with 6 equals 6. However, this one's different from the last one because this one is actually true. So that would make no matter what x is in this equation, 6 would always be equal to true. So so let's quickly make a table for that. So let's say you plugged in 1 for 4x plus 6. So 4 times 1 plus 6 is equal to 10. So 10 would be equal to 10. 4 times 5 is 4 times 5 plus 6. That is 26. So 26 is equal to 26. So that basically means that the equation has infinite solutions. So when you end up with a true statement, like 6 equals 6, 5 equals 5, or 4 equals 4, or oftentimes 0 equals 0, the equation has infinite solutions. So when you say the answer is infinite solutions, you would usually write just infinite solutions. Right. Next, let's just go into another example. So 3 times x plus 2 is equal to 3x plus 6. So firstly you have to distribute. So 3 goes into x to make 3x, and then 3 goes into 2 to make plus 6 is equal to 3x plus 6. Subtract 3x from both sides to cancel out x, and then leave 6 is equal to 6, which again is one of our special cases where it would result in infinite solutions. So this equation, again, the answer to it would be infinite solutions. And finally, so based on what we've learned, after solving an equation, you would probably get something. You would end up with one of these three results. So let's make a table right over here. So results to type to example. So as a result, so let's say you had x equals a number. So any x equals a number like x equals 5, x equals 4. So this would be one solution. And like x equals 5. Next, we have a false statement. So this would be no solution, or this again. And that's like that. An example is like when you're left with 3 equals 7, or 5 equals 2. And finally, we have infinite statements. No, infinite, yeah, true statement. So the true statement is when you have infinite solutions. And you're left with like something similar to 4 equals 4, or 0 equals 0. So these are the three types of equation results you can get for simple one variable equations. So therefore, don't forget that when it's no solutions, so when it's no, the two sides can never be equal. And when it is infinite solutions, the two sides are identical. The two sides are perfectly identical. And finally, when it's one solution, you would notice that like almost every equation falls into this category. So every equation. For this, you would result in like x equals 3. For this one, you would result in 4 equals 4. And for this one, you would result in 5 equals 3. So that wraps it up. So in this video, we went over Special cases when solving for x, like no solution or infinite solution. Don't forget to don't forget to do the homework linked in the description, and thank you for watching.